So we are back here at Uppsala Tech Meetup 18 about web development, and next up is Håkan from DICE.
Right, thank you. It was a long time ago since I presented last, and it's not that often you get these roller coaster kind of butterfly stomach experience, but I love it. It was been a while. So, as the slide says, my name is Håkan Rosenhorn. I work at I work at DICE, formerly known. We used to be named Uprise, sitting upstairs above O'Leary's, but now it's just DICE. It's all the same. So I generally call myself as a creator of things. I do whatever is needed. You can say as a whatever is needed stack developer, broadly. No, but seriously, I do a lot of mainly like backend system, distributed systems. What that means, it's more or less everything except what you see when you play the game. So it's everything from when you log in, from when you search for a server, when you fetch your stats, you fetch your friends, and all those kinds of systems that need to perform during load. Otherwise, during the years, a few projects, there's been a few. We have like Battlelog, we have different games that we've been part of, and most recently the Battlefield 1 game that has, I think it's about a year old. So today I am gonna talk some about our JavaScript usage inside of the game. Not that much of what kind of tech we use, but more from a different perspective. Like traditionally you have the browser, but we have a bit of a different approach than the browser. For those who haven't played Battlefield, who haven't seen this UI, this is how it looks. So everything that you see here is driven by JavaScript. You have like videos, you have transitions, you have tweens, you have focuses, and everything that you would expect from a high fidelity user interface in a game. With the exception, is driven by JavaScript. Right? Enough of that. A short history on how we actually ended up here. So we used to do a lot of web development traditionally, and we started our journey in Battlefield 4. We have had a small overlay that you can bring up during the pause screen, and it was built on WebKit, or with WebKit. We then moved on to when we started developing Battlefield 1. We wanted to evolve this and make it more central part of the UI. It was still WebKit, but we felt we were enabled to reach the fidelity that is expected from a modern AAA game. So we moved on and evolved, and today we have this interface that is driven 100% on the GPU, as there is no software rendering. So, well, it's used by the way, how many here knows or have used React? Just about 50%, give or take. Right, so yeah, we use React. We used a bunch of other popular things that you might expect in a typical web application, but those are not the things that I'm going to focus on, right? We have those. Okay. Instead, I'm going to talk some about a few things that we need to take into account. First of all, the constraints are a bit different when you work with a game. First of all, you have a memory budget, right? So typically on a PC, when you have your Chrome, it's not uncommon that it takes like a gigabyte of RAM, right? So take this and know that, let's say an Xbox 360 only has 128 megabytes of RAM. And on that, you need to have the game and then your like UI. So there are some serious memory constraints that we need to keep in mind. We cannot load ginormous textures. We need to clean up after ourselves. And the next thing is that you have something called garbage collection. And that is in JavaScript, I mean, if you allocate or use a lot of objects, they will eventually be cleaned up by something called the garbage collector, and they will reclaim that memory. So why is this a constraint? Well, you can't really control when the garbage collection kicks in. and since the garbage collector is usually single-threaded, in this case it will pause whatever you're executing, clean up the objects, and then let you keep on executing. So what this means in a user interface, you will do some rendering, it will freeze, and then you can continue. So we obviously don't want that. So what we have done instead, we have managed to defer the actually garbage collecting after we have rendered the frame. So once the rendering has happened in like software land, we offload it to the GPU, and then we let the garbage collector kick in and do whatever it needs to be doing. Third thing is the performance. So of course everyone wants like their website to be performant, but in most websites people don't care as much. Well, they do, but they don't. For example, take a site like Aftonbladet. You enter it and it kind of loads and stalls. You try to scroll and it doesn't, but you go there anyway and read it, right? That is probably not performant, but you go there anyway. You don't really care, you just want the content. In a game, people have very little acceptance if something just freezes and stalls and freezes. You don't want that. So you can definitely shoot yourself in the foot, and it's very easy and it's very noticeable when you do it, because people start posting Reddit threads. So this magical 60 FPS that everyone keeps talking about, it's even more important when in the game. So, right. So I'm gonna say most React applications use the browser and target the DOM, right? They work with HTML. Not everyone does. You have, for example, React Native that uses the native building blocks of the corresponding iOS or Android app. But in my comparison, I'm gonna stick to the most DOM examples, right? So in our case, we don't output HTML. We don't use the DOM as it's known today. We instead target the Frostbite engine, and the Frostbite engine itself targets like DX12 or DX11 and D3D. So instead of generating DOM elements, we generate an intermediate representation that we refer to as surfaces. And a surface can be anything. Think of it as a div instead. That is probably the best example that I have. So, and these surfaces have, just like a DOM element, or a div element, a predefined set of attributes that it can specify. It can set like color, height, width, bold, text size, etc. So traditionally, this is actually the web application, or the mobile application of the UI, and it outputs div elements as you are used to, all classical thing here. And this is actually the surface version. So instead of div, you have a surface, and you have some headers, and you have some other attributes. So they look fairly similar, right? So the way we transform these from instead of a DOM, we use something called a custom reconciler, and that's an extremely fancy word used in React. So in React, right, as also Johannes talked, it calculates when you want to change something. You call your render function, it returns a bunch of HTML nodes or some kind of representation of how you want your destination to appear on the screen, like HTML or DOM nodes. So what the React has a phase that is called reconciliation, and it takes your new tree, matches with the virtual DOM, and outputs the minimum amount of mutations needed to reach your destination result, right? And in React, you can actually change this reconciler. So React Native has its own reconciler, and there are some examples on the web how you can do this. You have to implement a bunch of methods, and you have to output, well, whatever you want. So the reconciler translates these surfaces into engine calls that we have exposed. So we can say, let the Frostbite engine know, like, we want to draw a square, fill draw text or whatever, draw a triangle. And this in terms updates like the engine internal representation of how the UI looks. So tooling, everyone loves tooling. I love tooling. So the tooling in web development is extremely good. It's extremely developed, and you have all the kind of modern things you would expect. So, I mean, we couldn't be, as we are taking the web development flows into the game, we, as people are used to a set of tooling existing, we of course need to at least achieve some level of parity. So if this would be a web application, no one would be surprised, right? You can just right-click inspect in Chrome, and you would see the corresponding element highlight, right? So we have a similar setup. This is the game running, and you can go to the React tab just as you would expect, and you can just highlight whatever element you want. And you can even like change text or whatever. You can modify the elements just as you would in a normal application. Then, of course, as I almost said, that you can like delete or edit and tweak elements. We also have like hot reloading. So here we have a bit of a toy example. I don't know if it's running. Yes, it is running. So one guy at the office wanted to show how you can actually demo the hot reloading. So what he did, he took like BF1. It actually says BF1. It is the actual game, and he kind of just removed the UI and made his own UI. We use WebStorm, right? Almost everyone uses WebStorm at our place. Some don't, but most of us do. And while he's editing, it's reflected in the game almost instantaneously. So that is you still have the same kind of iteration and speed as you would have in a traditional app that you use like Webpack or something. It just updates, right? And it maintains the state. Next. Right. So JavaScript engines. There are a bunch of them. Like Chrome has its V8, WebKit has its JavaScript core, and SpiderMonkey in Mozilla, etc. So as you noticed, we used Chrome there, right? And Chrome uses V8. We would love to use that. It would be awesome. You have so much stuff for free in Chrome. You have like the profiling, the bugging, the breakpoints, and all that fancy jazz. So we would like to take advantage of that, and we do. But there's a little bit of a drawback with V8. You cannot disable the JIT. And the JIT is a just-in-time compiler. So what it does, as you see, it sees your code execute. It mutates the code into a more optimized version. So why is this? I wouldn't say bad. JIT is awesome, but it has some security implication. As the code actually modifies itself, it means that you have to have like executable flag on code. So you could, in theory, inject your own code and like run on whatever you want. So the big first party, as I will use the term first party, and that means in general Sony and Microsoft, they do not want JIT enabled. Maybe some of you have seen that you can run Linux on a PS4, and the way they did that is I think they actually used WebKit. They injected their code in a executable enabled memory flag, and then they kind of bricked it and they booted Linux. So that's why they definitely don't want you to run JITted content. So therefore, we use JavaScript core inside the game. But when developing in general, we use V8 to take advantage of and there are some differences. An unspoken rule, if you haven't tested it in JavaScript core, it will probably break, but it happens. What do you have more? We have something called UI transitions. So the Frostbite engine has its own UI framework, right? I told you there was a lot of memory budgets, and we can't really use this everywhere. A typical place where you would use the engine UI is like the HUD. Like you have your ammo, you have your health, you have your squad mates, and that is a super compact, memory efficient UI framework. And sometimes we need to jump between these as you go into the game. And the way we do it is here's one example. So this is the JavaScript framework, and does it work? I'll try again. Oh, it does. Okay. So we enter and want to play operations, and now you have entered into the engine UI. We can go back and we try to transition out back into the JavaScript UI. So we have the ability to blend these inside. Since it's always the Frostbite engine that renders both the JavaScript and the in-game, we have the ability to control how they are blended. So this is maybe one of the earlier transitions that were made. So if you know what to look for, you can see when it's actually blending. But something that happens now and then is that when QA is testing, like sometimes the bugs meant for the engine team comes to us and the other way around. So I guess that is at least some level of minimum achievement there. What else do we have? We have the game communication, right? So the JavaScript parts need to be able to talk to the game. And for example, it needs to tell, I want to re-render myself. I want you to update this screen, or other classic parts. So what we have is a global object, or an object injected by the engine into our global scope. And on that object, we have things like the render, the reconciler. We can like do this mutation, change this. We also have what we refer to as the game API, right? You can fetch friends. So we do a JavaScript call, it goes to the bridge, and it goes to like Sony or Microsoft and fetches our friends, and then it gets passed back. We can play sound, we can play video, we can trigger first-party flows, and that would typically be, I go to the store and I want to buy this. And once you go that, you are required to actually use the Sony checkout flows, since we don't want to handle like credit card details and those type of things. And you want to use maybe you already have this set up, right? Input handling, like all input first goes to the engine and then it kind of pops back out through this object. Allows us to do basic stuff like navigation. Events is also a big thing. We need to be able to signal state back and forth. Things like the user came online, your friend come online, you got invited to a game, or the game has loaded in the background, it is now ready for you to join. Do you wish to join? Yes, no, and those type of things. After that, we also have UI updates. So this may be a bit something that people take for granted in the web world. I mean, you press F5 and you have a new version, or you just upload something to your web server or your Amazon S3 bucket, and it's just everyone has it instantaneously. This isn't the case when doing game development. Traditionally, you submit a patch to Sony or Microsoft. It is like a battery of tests and certification process and requirements you need to fulfill. For example, when you want to do something, it's always like the green button. And if you want to decline something, it's always the red button. If you kind of mix those up, you will fail the certification process. So that also means that it takes a while to change something, right? So instead, we want to reuse the web flows, the interaction and agility that you come with just being able to update. If you have a bug in the morning, you can actually fix it like by lunch, and that is something that we really missed from the web flows. So today, as we are actually running web, we have the ability to deploy these type of patches without doing a full certification process, or without swapping the game executable. We can just push a new bundle to the client. And we have the ability to push both what we call mandatory. Let's say that the bug that this fixes is so critical, we want everyone to have it, or you might, or I said like, no. The second theme is seamless update or silent updates. And what those means that as you boot your client or you boot the UI, the game will check, is there a new bundle available? Yes, there is. It will download it, put it on disk, and the next time you start the console, you will just have the new UI. It is not mandatory, but you will get it. And the third thing that has saved me a few times is that you can actually push a bundle to specific users, or a specific percentage of users. Let's say that I do my fix and I just deploy it to myself. or to my friends or to just QA, and they can verify, yes, it works. It's safe to push it to everyone. The worst thing you can do is to push a bundle that bricks everyone's consoles. That would not be something that I would like to read about on Reddit. So this is typically what it looks like. This is a mandatory update that someone got. It will get downloaded, it will get applied, and then the UI will kind of reset with the new bundle. And that's it. So this was a typical mandatory, but if you would have had a silent one, you wouldn't have noticed it. And we do this, I wouldn't say super often, but now and then if the need demands it. Also something that we call one UI. The benefit of running this in the web, we have multiple games, right? We have both BF4 and BF1. So is it actually the same UI running in both? It's the same, perhaps not exactly the same bundle, but it may or may not be. But they do support each other. So for example, you could be in BF1 and go browse BF4 and see whatever people are doing in there. And if you want, like, check if your server is free. So there's I'll have a later example of that. So as you come into a new game, you will still recognize it will be the same thing, the recommendations, you have your friends to the right, and you have like the foldable career or whatever you have on the left. It will be the same experience for all games. So, and this is also something that we call cross-browsing and cross-launching. So what you can do, this is BF1, running in the BF1 executable. You can navigate to BF4, same UI, and you can go to your server browser, select your favorite server, press join, reserve a slot, and if you want, it will launch BF4. So if the server was full, you can just hit escape and continue playing on your BF1 server, right? So you don't have to quit and, oh, maybe no, my server got full again, I can't get back in, sorry guys. So this saves a lot of trouble for people. So a few takeaways. We have both good and bad pieces with its setup. The better parts is, of course, there's a lot of tooling that we can reuse. We don't have to reinvent the wheel. We can just take all the nifty features that exist in Chrome, for example, right? There are more people that know React than knowing Frostbite, right? So it's a bit easier to find the web developers who can adapt and build UIs than it is to find experienced Frostbite developers. We have the ability to reuse the existing web iteration speeds by doing updates to the UI over the internet without doing this lengthy certification process. And we can share the code between both different games, but also through the mobile apps that we have. Yes?
Question regarding testing the UI. In the web development, we have the Selenium test for testing the UI. Do you have something similar?
We have both unit tests, we have end-to-end tests as well. So we have the game when running in test mode, it actually exposes like a web server. They can send commands, and we have nightly builds that kind of traverses and clicks and everything. So maybe I should have brought one, I'll think about it next time. But it looks really funny since they don't care how fast you click, so it just mushes through the screens and just join service, quit, enter, select friend, add. It looks really funny when you look at it. But yes, we have end-to-end tests that run nightly on both PS4 and Xbox. So I think there's like a farm of like 100 PS4s that you can allocate and run your tests on. But mostly, if possible, unit tests, since those are much cheaper to run. Then we have 4 lesser good parts. First of all, performance does not come out of the box when using React and all these fancy tools. Is still as easy to shoot yourself in the foot. The only difference is it is really, really more noticeable when you have performance drops or frame drops in a game, since a lot of things are moving around and sliding. So that is something that still requires a lot of attention. The next thing is the garbage collection. I mentioned this, but it can kick in when you really don't want it to. And I think we still have some frame drops here and there, but we are working on them. This is maybe the biggest minus. We have a lot of native developers, as I call them, C++ developers, and we have a lot of web developers, right? So when a native person sees like a JavaScript stack trace, it's just like a black box. And it's the other way around. When you get like a pop-up assertion that you're able to reference memory at 0x non-null, that is equally black boxy for them. So, but this is something at least something we can work on. I mean, the web guys can try at least expand their knowledge into C++ world and the other way around. And the last thing, the memory budget. This is something that tends to make its presence known when you're closer to shipping, right? So once you think you have all this figured out and you run the final thing, and then it just crashes. Like, okay. So someone pushed its latest 4K background image that allocated 40 megs of RAM, and it just exploded. Happened before, will happen again, right? So we are hiring. We used to be named Uprise, now it's just DICE. We are looking for both front-enders and back-enders. Back-enders would be like Scala, the JVM. We also like native developers for C++. And let's click. That is it. Any questions?
I have like 20 questions.
Okay, shoot.
Why does using JavaScript enable you to push changes past the checks with Sony and those guys?
I believe partly trust, partly that this is something where I believe more and more games and the community is expecting these days. So I think they know that they cannot keep up since the certification process takes so much time. And also, this is a lesser risk of just changing this than changing the entire game.
But it sounded like they're testing all the things that you change, like pushing green button is for doing something.
Yes.
All that.
So a typical thing that they would test during certification is like, I don't know exactly how the certification goes, but a typical issue that you would get is like, well, you're driving this tank on this level in this type of sunlight. When I yank the network cable, I end up in a technical hang. Right? So that is like the best ticket to get. So those type of things they won't need to test again, since we're not touching those things, right? So all those kind of predefined technical requirements don't need retesting, since we haven't changed those. Well, you can still have a technical hang, but not because of those reasons. Yes.
How much work and time did you spend on building the tooling?
Depends on what tooling. I mean, Chrome came for free, right? The hot reloading came for free. But I would say the majority of the tooling was either, I mean, we have other tooling that isn't shown here, how you can like tweak. So this is just the web parts of the tooling, right? Mm-hmm. We have the equivalent on the native or on the engine side of how these mutations get when they get intercepted and assuming that they do the right thing. So there's a different pattern of tooling there. But yes, it took a while, and we're still developing the tooling as we go. Hard to say. I mean, there were a few people during a year or two or so.
So you're constantly spending efforts on tooling?
Absolutely.
It's an ongoing process.
Absolutely. I think I believe that if you need to do something twice, it could probably be replaced by automation, right? So tooling, in my eyes, is the key to being able to iterate fast. And without that, I think you will just be left behind.
And the left behind note, how many of your competition do this?
I don't know.
So you don't?
Well, we know, for example, games like I've seen. This is my private notes or mental notes. For example, Battlegrounds. I know they run like WebKit, and I think they are currently. I mean, they are able to have the same ability to update if they want to, but they still have the same issues that we had in BF4, that like doing animations and transitions in WebKit and a garbage collection. And we have seen a lot of games that do this WebKit approach. So I think it will just be more and more popular. Either you will go this route, that you can update the UI, or you have the other route that you can push game updates faster. Yes.
How do you run the UI for Battlefield 1 on 128 megabytes? Like my Slack instance takes like 2 gigabytes.
Yes, but that's because you have like an entire VM under Slack.
Yeah.
So that's why I said that there are actually two frameworks. So when you are playing a level, more or less everything of that 128 megabytes are used by. So let me back it up. So we did have BF4 on like the 360 and those, but it was only used when you are like in the main menu. There's no level, like multiplayer level loaded. So once that is loaded, there's like no space for WebKit at all. So just starting JavaScript core takes like 25 megs of RAM. So as you are in the like starting screen on the menu, so as a front end as we call it, there is traditionally where you have the entire memory budget for yourself. But as you move into the game, that's why we need to move into a more denser C++ UI. But it worked it does work on 360, but it does require almost all of those 128 megs of RAM, and that's mostly due to, well, WebKit being WebKit.
Yeah.
You can't control much of what gets loaded. There's a lot of bloat in there.
How do you defer the garbage collector to after the rendering on your CPU?
I haven't written that code myself, but I think as I see it, the way it got presented to me, a fellow coworker locked himself in for 2 weeks with JavaScript core, and when it came out, the garbage collection was deferred with some hack and black magic. No, I don't know more than that. But he said it, as long as we offload it to another thread, that thread being like the game engine thread, since JavaScript is still single threaded, once that is done, you can do whatever you want, basically. Yes.
What lessons did you learn running JavaScript for a game that would be applicable for web developers?
Typical helper frameworks, let's say underscore and other popular thing where you just sprinkle calls all over, and you don't care if you do like 10,000 or 100,000 allocations, and if the garbage collector kicks in, it kicks in, it doesn't matter, right? So those type of, I think people have become more aware of things cost. Don't do like long loops, try to opt out or early out as fast as possible, those type of things. And also people who come from like the native side have more respect that things takes time to execute, and that is also why we had like a lot of the first naive approach was to just build whatever you want, and then we started having like frame drops, and the garbage collector kicked in since we allocated too much objects, and etc. etc. So that would probably be the biggest difference. And test more, since you can't just F5 or redeploy instantly. We do have more tests, and people have more respect for testing. Shoot.
Me? Okay. Again, do these things, do the game engine and the JavaScript interpretation or execution run on different threads?
Yes. Well.
And events, do they go through the game engine and pop up to the UI layer or thread?
So the game engine is always the one in control, right? So the game engine can suspend the execution of JavaScript once it goes like into a multiplayer level, and kind of unload the UI to conserve memory. And all input, everything like sound is played through the engine, so you could like play sound through JavaScript and it will get mixed properly with the multiplayer level. That is something that just handled by the engine. So the trick is, or the challenge was to make sure JavaScript core worked with the engine, not against it, since usually all these are, well, the world is mine, I can do whatever I want in a browser, I have total control. Right? This isn't the case. You need to play nice with the engine. So to answer your question, yes, everything goes through the engine and then it kind of pops back through this global object that we talked about. Everything like inputs, events that you are about to be suspended, do whatever you need before you die in a second or so. Those type of events. Did that answer your question?
Yeah, sort of.
Okay. Yes.
Yeah, I haven't played that myself, but as I understand it, what you build in the web is not actually the game, but kind of the navigation between levels. So when you actually play, then you're not using JavaScript, right? Or
No. Once you have loaded into a level and are in control of your character, you are not using JavaScript anymore.
What you're building is like navigating between.
Yes. The user interface, everything that you would adding friends, accepting, joining servers, leaving, kind of maybe leaving servers, and like clicking recommendation, reading news, those type of thing. All of that. I'm not gonna say all, but most of it is JavaScript. There are still some screens that is in-game UI, and we do mix, for example, like settings, volume sliders, and those type of things. There's nothing stopping us from doing those, but they work, so there was no need to replace them. Right?
But like inventory and HUD, they are not JavaScript.
No. And once you have loaded into a game and you have the HUD, those are the engine UI. Since every single megabyte of RAM will be used by the game. And using 25 megabytes to load JavaScript core is unacceptable. It's just too much. Think of that when you have your Chrome tab pulling a gig. Or I looked today, my IntelliJ was pulling like 10 gigs of RAM. So every single RAM megabyte counts. This is not as big a problem on PC, but on like the consoles, you cannot upgrade your RAM. You have what you have, like I think it's 2 gig or something. I don't remember. But once you go above that, you just crash. Right?
It's me again. Yeah, so if the game engine controls the whole thing,
Mm-hmm.
but when you switch a game, you load a new game engine.
So yes, so as it is the same UI or the same, it can be the same bundle, but it doesn't have to. It can be different versions, like different amount of commits. But let's say for simplicity, it is the same bundle. So when you start BF1, you load out the interface that may or may not be shipped on disk, right? And when you go into the different sections, you are still in BF1 executable. But once you hit join, as you saw the counter start happening, it will stop the BF1 and launch the BF4 executable, and will put you in the same state as you were before, but with a different physical bundle, since it will be loaded from the BF4 directory or save content, or since you may have different BF4 specific fixes that went down to that bundle, right? We maybe don't want to risk breaking BF4. That's why we only update BF1, but it is similar enough. So, I mean, for example, BF4 and BF1 they are quite a few years apart, right? So BF1 might have like DX12 or different type of shaders, etc., etc. Different features that weren't available in BF1.
So the screen goes black?
Well, once you switch executable, it will be whatever you would expect. I mean, you might see your desktop and then you will pop back up. But you will end up in a place where you recognize where you left off, right? So there are some technical limitation what can and cannot be done. I don't know if someone has played like Halo Master Chief Edition. They do a similar thing where you can just switch games, but that is still within one physical executable. They have just bundled all the games into one, and that's what makes it a better experience. Any more questions? In that case, I will let you go and mingle and drink beer.
Thank you very much.
Thank you.